Yes, good afternoon, everyone, and it's a pleasure for me to be able to speak to you all today, and also to congratulate you for the new position here. If you look at the title here, you can probably understand that there are some similarities with the previous presentation, and you will even notice that some of the slides are more or less identical. But this will be a slightly different perspective, and it's too late now to redo the presentation. So anyhow, let's go ahead and see what I have to tell you. Just go ahead. Yeah, so this is basically the outline of my presentation. I will mainly talk about these first topics here. What is the problem, what is the solution, and what are the obstacles? And then I will talk a little bit about the last points here. And I realize this is a very informed audience, so in a way I will perhaps blow in open doors, but we will see what happens. And for some other audience, I would be worried to have rotten eggs thrown at me, but I don't think this will happen today. Okay, so what is the problem? This is a problem. What you see here is a graph of the carbon dioxide in the atmosphere the last 450,000 years. And you can see that during all of this time, the concentration has never been above 300 ppm. And as you see, the concentration has increased incredibly during the last 50, 60, 70 years. And this diagram was actually drawn or taken from NASA's webpage in 2013. And now if I put in the data for 2024, you can see that there is a noticeable change just for these last 10 years. So this is really alarming, of course. And if we look at the temperature, the average temperature, global surface temperature, we can see that there is a connection here between the carbon dioxide emission, carbon dioxide levels and the mean surface temperature in the world. And of course, you can still ask whether it's our fault or if it's someone else's or some other natural causes. But I think we can. This graph shows that it's actually our fault. What we see here is the result of simulations of the global surface temperatures. And as you can see, this is the history, so to say, what's actually happened. And with the same simulation programs, we can just take out the emissions from our activities, and then we would end up down here. So we can show that without the emissions from human activities, we would actually have about the same temperature levels as we used to have since the 1850s. So I think this is good proof that it's actually our fault. And now during the last year, a lot has happened actually. So this is the global surface air temperature in July for the years since 1940 to 2023. And you can see that there is a steady increase, but you can also see that there is a drastic increase during the last year. And we can also look at the last year from another perspective. This is showing the daily sea surface temperatures for most of the oceans from over the years. And down at the bottom here you see further back in time, and then the red line shows the temperatures during the year 2023 to 2024, and you can see that there is a big gap between the data for this year and all other years. So suddenly the sea temperatures has increased quite a lot, much more than they ever increased before. And this is not yet explained why this is the case. So this is worrisome, I think. If you just look at the temperature data for 2023, we can note that 2023 was the hottest year ever recorded, but recordings started in 1850 or so. So how about temperatures before that? Well, just recently there was a report reported on in Nature where they claim that 2023 was actually the hottest year in 2,000 years. And how can they find out that? Well, by looking at the tree rings on a lot of trees all around the northern hemisphere. This was deduced from that data. So global warming is happening. It's happening at an increasing rate, and we really don't know what is happening during the last year because the increase has been more faster than we expect. This is also showing the temperature increase. The black line here is the 5-year rolling average, and you can see that it's increasing, but it's lagging behind, so to say, as if it's a 5-year average. And the dots here indicates the days with the temperature for individual days. And you can see that there are some days where we already reached more than 2 degrees above the pre-industrial baseline. Yes. So of course this causes a lot of problems. Heat waves, droughts, wildfires, floodings. And these are just headings from newspapers which I took from last year. And I'm sure that you have seen all of this. You've seen the consequences of the global warming. A lot of photographs of this. This is from Germany a year ago. And yeah, you can find any number of news about the effects of global warming. But one effect which is not often talked about is actually this. This is showing migrants moving towards Central America, towards US. And you can of course say that, well, this is not because of global warming, but I would say that it is at least partly because of global warming. The conditions are changing, and that is forcing people to move. And in the near future, I fear that we will see a lot more of this. People will not longer be able to sustain themselves in parts where people have been living for thousands of years, and they have to move. And I'm very worried that this will cause a lot of unrest. So, why do I tell all of this? We need to have a solution to this, of course. And the solution so far has been the Paris Agreement. All the countries, or almost all the countries in the world, has agreed to do something about this and try to limit the temperature increase. And this is the Paris Agreement in a nutshell. So on the vertical axis, you see the annual global total carbon emissions. And the different curves relates to different scenarios. According to the Paris Agreement, we should keep well below 2 degrees, preferably at 1.5 degrees increase. And from these graphs you see that to reach this, we have to have not only zero emissions, but negative emissions after around 2050 or 2060. So not only stop emitting carbon dioxide, but also absorbing carbon dioxide from the atmosphere. And even though I speak to a lot of people from universities and talk about their research, it seems a lot of times that people are really not aware of this still. They sort of have pushed this out of their mind. We have to stop using fossil fuels. And of course all the countries in the world, or most of the countries, have now agreed on a day or a year when they should be carbon neutral. And you can see from this drawing or this slide which country, which year this is for the different countries. And you can see that for most countries it's 2050, just like Europe. And that's not a very long time ahead of now. You probably remember when we celebrated the year 2000, and that's 24 years ago. And this is more or less the same amount of years ahead of us to 2050. So the question is, will we reach the goals? And the UN has sent out reports saying that we may not do this. We may not reach these goals. We need to do more to reach the goals. And recently there was an article in The Guardian where a lot of scientists, climate scientists, were asked, what do you think will be the global warming at the year 2100? And each little box here represents one person, and you can see that 77% of all the climate scientists expected a rise of at least 2.5 degrees. So the 2 degrees goal is, according to them, most of them, out of question. So, what do we do? In Europe, we have, as we already heard from Thomas, several agreements on or decisions about how to limit the global warming or the release of greenhouse gases in Europe. We have the Fit for 55. I don't need to go back to this again. Thomas talked about this a little bit already. So we have targets for 2030 and now also for 2040, or at least suggested. But I want to point to this diagram just to show that we are still heavily dependent on fossil fuels. It's about 70% still, which is of the energy supply which comes from fossil fuels, and in worldwide it's about 80%. So it's just slightly better in Europe. We can see that the green portion here is increasing in size. So we're doing something with the renewables. They are increasing, but we are very far from the goals. And if we want to get rid of this 70% to somewhere out to the right here, we have to do a lot better than we have been doing so far. So what is the strategy to reach the goals? Now I'm only going to talk about the building sector. That's where we have the heat pumps, or also some in the industry, of course. I think these numbers come from European Heat Pump Association. At least is from Martin Forsén's presentation. And so about 40% of all energy in Europe is used in buildings. And this corresponds to about 37% of all greenhouse gas emissions. And there are many, many millions of space heaters. There are different numbers circulating here, but according to this source, it's 129 million space heaters in stock, and many of them are old and inefficient. And if we just would replace them at an ordinary rate, it would take 25 years to replace all these heaters. One question comes up, of course. Why don't we use biofuels instead? And of course, this would be an option, but is it good enough? There is a lot of discussions in the EU right now what we should do about the forests, whether we should allow them to grow, whether we should think about keeping the forest is also a way to absorb carbon dioxide from the atmosphere. And the most obvious way actually to absorb carbon dioxide from the atmosphere would be to not cut the woods. So just to look at, I could talk a lot about this, but I will just show you one slide. This is from Energy Post, and you can see the gray circle. The circle here represents all the energy supply, and about 17% of this is renewables. And out of this 70%, about 60% is actually biofuels. So I think this was a number which surprised me quite a lot. I didn't think it was so much. We see a lot of wind turbines and the solar panels, PV panels, but actually the biofuels is a larger share of the total renewable energy sources in Europe than the other ones. And out of this 60%, which is on the bioenergy, 75% about is used for heating and cooling. And this may sound also strange for us living in the city, but if you go out of the city, up in the mountains, people chop the tree and use that for heating during the winter, right? And in the Scandinavian countries where we have a lot of forest, there are lots of wood residues from the wood paper and pulp industries which are used for heating. Yes, so I will not talk a lot about this, but I will just give a few sentences here. It's questionable if harvest of biofuels can be increased. I don't think so. Perhaps a little bit, but not by far enough to substitute this 70% of fossil fuels which you are using now. And when we talk about biofuels, we should of course differ between wood, good wood, and waste wood. Of course, we can use some biofuels even in the future, branches and roots and other things. And also, something which is not often talked about is the connection between the price of the biofuels and the price of fossil fuels. We could see that a couple of years ago when the gas prices went up, the biofuel prices went up at about the same rate. And the day we're forced to stop burning fossil fuels, the prices of the biofuels will definitely go up because there will be much more competition. And we should also remember that the biofuels are very good for producing liquid fuels for transport, for ships and for airplanes. And perhaps they should be prioritized. These areas should be prioritized. So the reality is that fossil fuels will be phased out, have to be phased out. Biofuels will not be enough. Synthetic fuels produced from renewables are inefficient. I mean, we talk about hydrogen, but if you use electricity to produce hydrogen and hydrogen to heat the building, then you have, I mean, it would be totally stupid, right? And renewables and nuclear, they come as electricity. So the conclusion is that we are moving towards an electric society. We think about all our gas grids and the oil tankers, etc., etc. But that's out. In a few years, they will be out. We'll have an electric society instead. And of course, this has been realized, as Thomas already have touched upon. Electrification is one of the key pillars which the new policies are built on in Europe. And yeah, I just cite a couple of statements in the documents here. In the residential sector, the share of electricity in heating demand should grow to 40% by 2030 and 50 to 70% by 2050, and even higher in the service sector. And for the whole world, I mean, if we go to International Energy Agency and see what they state in their heat pump outlook, they say that the proportion of heating equipment sales accounted for by heat pumps nearly triples by 2030 and continues to grow thereafter. Heat pumps become the leading heating and cooling technology in buildings worldwide by 2040. So it's not only here. And this is from a recent report. I'm not sure I even believe this number, but I hope they know what they're saying. Installation of about 600 million heat pumps covering 20% of the building heating needs is required by 2030. So this is from IEA, one of their report. And just showing what this graph would look like, the bottom part here is the extrapolation of the rate we have today, and this is the rate to reach these 600 million heat pumps. So it's exponential growth. And the exponential growth, I think Thomas showed this already. There's a deviation during 2022, but I think we can expect this to continue growing exponentially. And this is just showing this exponential growth. I think this is also from the European Heat Pump Association. So predictions based on the statements in the EU, from the EU. These graphs look the same, but if you look at the scale, this stops at 3 million, and this one stops at 14 million. So it's just an extrapolation, and you can see that the expectations is continued exponential growth. This is another statement from the European Commissions, where they say that we should install 10 million heat pumps per year by 2027. And this is more or less what the previous slide showed also. The European Heat Pump Association also showed this, and stating the expectations for different countries. And we can see that France is in top, Germany is second, and then we have all of the other countries. And the total sum here is 43 million heat pumps up to 2030. So that's what the business organization has declared. We talked already about the European Heat Pump Action Plan, which was expected, which never was, but was postponed. So we will see what happens to that. In France, they already have a national heat pump action plan taken. And according to this plan, they should produce 1 million heat pumps per year by 2027. So they are already on their way to let their heat pump industry grow very much. We saw this picture again. So the EU has, or the countries rather, have bans on fossil fuels in different countries. I don't need to talk about that again. But many countries have also subsidies for heat pumps, either in new buildings or when renovating buildings, or in some cases in both. We should also remember that the heat pump markets are very differently mature in different countries. This shows the chance, we could say, that a buyer would buy a heat pump rather than something else. So it's you can see that in the Scandinavian countries, Norway, Finland, Sweden, Denmark, the chances are more than 90% that if you buy a new heater for your house, it will be heat pump. On the other hand, you see at the bottom here in Hungary and UK in particular, it's the chance is just 3%. So it's a huge difference between the different countries. Yeah, I don't need to show this again. This to you, you know this, that the heat pump is much more efficient than a gas heater. And looking at this 70% fossil fuels which we have to substitute, this also means that we don't have to substitute all of this 70% because the energy use will be a lot lower when we start using electricity as a main source rather than fossil fuels. So what are the obstacles? Can we use fossil gas as refrigerants, F-gases as refrigerants in the future? Yeah, I think I will skip that in the interest of time. This is showing the distribution of different types of heat pumps on the European market. So the amount of air-to-air heat pumps are decreasing, air-water is increasing, and water-water is also decreasing a little bit. And this is interesting because the air-to-air heat pumps are mainly imported from Asia, while the air-water heat pumps and the water-water heaters are to a large extent produced in Europe. And of course, this has an effect on what refrigerants these heat pumps have. So this is a distribution of heat pump models offered on the market, ordered according to the type of refrigerant. And you can see for the 3 years, 2021 to 23, that R32 is increasing, 410A is decreasing, propane is actually increasing also and getting close to 10% here. And this is not the sales, this is the number of models available on the market. This is an estimate of heat pumps sold in Germany with different refrigerants. And this is based on figures from Fraunhofer, I would say, and it is based on when you buy a heat pump, you expect to get some subsidies, and to get the subsidies you have to fill in a form. And going through these forms, basically you can find out what refrigerants are used. So it's not the sales, it's these forms which people have to fill in. And you can see once again, R410A is decreasing, R32 is increasing, and R290 propane is increasing quite a lot. So in this slide, it looks like the share is about 20%. Yes, and I could say also that similar numbers are found in France. If you look only at the air to water heat pumps in France, the figures are expected to be about 25% propane, and probably this would be similar in Germany if we just looked at air to water heat pumps. Well, we know Kigali Amendment to the Montreal Protocol forces us to phase out the F-gases. All the countries in the world to phase down at least F-gases. In Europe, we have the new F-gas regulation, which actually phases out HFC refrigerants. Not HFOs, but HFCs. And this is supposed to be done by 2050. We also have bans for certain products, with certain refrigerants. I'm sure that you are well aware of this, many of you. And so for small systems, less than 12 kilowatt capacity, no HFO or HFCs will be allowed after about 2035, different for different types of products. And also the larger systems, they can have refrigerants with GWP. They have to have GWP lower than 150 from 2030. So there is a tendency towards low GWP refrigerants, definitely, and for small systems we will also have a phase out of the HFOs, not only the HFCs. There is an additional problem, and that is the possible ban of PFAS. So PFAS, as you probably know, is a group of substances, tens of thousands of substances, of which some are dangerous, and we don't have a clear picture of which ones are dangerous or not. So in Europe there is a suggestion to phase out all PFAS substances, and that would be including almost all of the refrigerants, synthetic refrigerants which you are using right now. So how will we handle the refrigerant problem? Synthetic refrigerants are strong greenhouse gases or belong to this PFAS group. Phase out of F-gases decreases the available amounts of synthetic refrigerants, and the increase in the heat pump sales, exponential, will require substantially more refrigerant than we had before. So the industry has a problem here. And the natural alternatives are flammable and or poisonous. But in my opinion, we will have to learn to design safe systems with flammable refrigerants in the future. I realize that my time is more or less running out here, so I will just show you a couple of slides. This is, I believe that the heat pumps in the future will be considered as part of a complex energy system. We will use the heat pumps to even out the energy prices and the availability of electricity by storage. So this is an example of heat pump with a storage connected. We will find heat pumps with low charge on this, so you can use them safely even inside. For multifamily houses, we don't want to see something like this, but there are several different solutions available for this, and I know that Fraunhofer, for example, is working on this. Perhaps we'll hear more about this in a second. We can also use borehole thermal energy storage connected to the heat pumps. We can use aquifer if that is possible, and all of these solutions require heat pumps because the storage temperatures are much too low. We see already built-in heat pumps in many of the whiteware we buy and the electric cars. In district heating in Sweden, we already have some heat pumps in the district heating systems. But I guess that in the future we will see much more. In the rest of the world, district heating is almost totally based on fossil fuels, and we cannot do that in the future. So just to show a couple of pictures of the heat pumps in Stockholm, and also from the IEA, they in their future of heat pumps, they predict that district heating heat pumps will be important also in the future. We could also talk about low temperature grids, smart grids, and of course this requires heat pumps in every house because the grid will have a too low temperature. And also final slide more or less. I believe that we will see more heat pumps also in industries. So we know that there are already heat pumps available which can produce heat at 150 degrees or so. There are large such heat pumps installed already, and so the technology is there, and we know now from the district heating grid owners that they are very interested in this. We hear this from the companies. So with that, I go to the final slide, and I will leave this on, and you can read it once again if you want. Thank you very much.